Good evening. Welcome to the session on Apache Atlas, the governance for your data. I am Madhan Neethiraj. I am with Enterprise Security and Governance team in Hortonworks. I'm a committer and PMC on Apache Atlas and Apache Ranger projects.
Hi, this is Suma, and I've been working on Atlas in Hortonworks from the past couple of years, and I'm part of the Atlas PMC team as well.
So this is standard disclaimer, and we'll start with the agenda.
Yeah, so I guess there have been a lot of talks on Atlas, related talks to GDPR. So this talk is going to focus mostly on Atlas and a little bit on classification-based security with Ranger. So we'll start off with a brief overview on Atlas and focus on some of the important features like data provenance and classification and how that facilitates data governance. We'll also focus on how you can effectively search through data assets in your metadata catalog and in your data lake, and we'll drill down into the architecture a bit. So the whole session is going to be hands-on, and it will be interlaced with a demo for all the features in Atlas. And after that, we'll be covering the roadmap and open up the sessions for Q&A. So to introduce Atlas, so Atlas' vision is actually to provide a set of core foundational data governance services for the enterprise data ecosystem, both with the Hadoop ecosystem and also outside Hadoop with respect to data warehouses, data located in data warehouses, and or even in an RDBMS. So, and most of this is metadata driven. So for example, you can have thousands of data sets being ingested in your data lake every day. These data sets could be processed through various processing systems through Storm, Spark, or Hive. And these data sets could be spread over different stores like HDFS or Hive or data warehouses. So Atlas actually keeps track of technical and operational metadata for these data assets, and it also associates lineage or provenance information with these data assets and the transformations that are applied on these data assets as and when data flows through these processing systems. And also it allows you to categorize your data assets using classifications and also to associate business context with these data assets. So for example, a Hive column could be classified as personally identifiable information and later used to apply governance policies. Or you could associate business or a semantic context like claims or life insurance with your data assets for effective search later on. So to search through your data lake for data assets, it exposes two types of searches. One is a free text search and another advanced search. We'll talk about this later in the presentation. And with respect to integrations, we have out-of-box metadata and lineage ingestion with Hive, Scoop, and Storm. And for the ones which are not out-of-box, like for example, if you want to integrate with Spark, there are APIs which are easy to use for custom metadata ingestion. You could also ingest lineage as well. There is also integration with Ranger for security-based policies based on data classifications. So at the core of Atlas, there is a metadata repository which ingests all this metadata. And to capture all this metadata, you need a schema or a meta model. And that is available out of the box for Hive, Storm, Scoop, HDFS, Kafka, and HBase. For the non-out-of-box ones, Atlas allows you to capture any type of technical, business, or operational metadata by allowing inbuilt types, by actually providing some inbuilt types and the meta model. So you can actually create models dynamically at runtime, and then that is available for immediate use. There are also APIs to register these custom models. So Atlas, when it was initiated, it was started off as a joint effort with a set of companies that were spread across verticals like healthcare, insurance, a global financial company, then oil and gas, retail. So we have collected what requirements both horizontally and vertically across these verticals, and we're able to assimilate them into Atlas. And this was an effort that was kickstarted off in December 2014, and it was incubated in May 2015. After that, there were like two major releases. The first one was the HTTP 2.5.3 release, which is also the Apache 0.7.1 release, which had high availability support and security-related enhancements like LDAP authentication and authorization. And we also added classification-based security for Hive. There was also a major effort to make the UI easier to use, and it was revamped in that release. The next major release was Apache 0.8, which is the HTTP 2.6 release, which was just released before the summit. It had a very simplified search UI and simplified APIs. We also added classification-based security for HDFS, Kafka, and HBase, and Knox single sign-on. There were a bunch of performance and stability improvements as well that were added as part of this release, so you should see a lot of improvement in Atlas performance after this. There have been code contributions majorly from Hortonworks and IBM, and some contributions from Athena, Merck, and Target as well in Atlas. And it has gained a lot of traction in the past 1 year, and a lot of code contributions being added as we speak. So let's now talk about one of the important features in Atlas, which is data provenance. So Atlas tracks both lineage and impact. So lineage answers an important question as to where the data asset actually originated from, or if you want to track the source or provenance of a given data set. And it also tracks basically the upstream path as the transformations takes place on data set and resulted in the current data set. So we'll switch over to a demo to illustrate that. So we are tracking actually lineage here for a data set. So this demo is oriented around an employee data set, which consists of a bunch of Hive tables, mainly departments and employees. It keeps track of title information in a titles table. So the data set that we are tracking lineage for here is an employee department titles table, which is actually derived through a transformation in Hive, which is a create table as select that was run on these two input data sets, which are also Hive tables. And the transformation that was run was actually a join that was done on these two data sets on an employee number column. So you can actually drill down into what transformations took place while generating this data set. And so the process, as you can notice, are indicated in a blue notation, and these processes could have n number of inputs or any number of outputs. So if you want to track the data provenance all along this, for this data set to its given source, you have these tables which were actually generated. The titles table was actually generated through a scoop import. You can see that it was actually imported through a MySQL table and into a Hive database called employees and into a table called titles here. And other input data set that is actually a flattened table that was run through a Spark process. So you can actually go through what Spark transformation was applied on this data set. And so the input to this were actually 3 different Hive tables that were flattened into an employee department flattened table. And these 3 tables were in turn again loaded through Scoop. So you can actually see the transformations and track the whole provenance through this. In terms of impact, so it answers other important questions like how is the data set being used further down in the downstream path, and all the transformations that were applied on it after it was generated, and what are the data sets that does that data set actually impact. So let's look at impact here, so we can actually drill down into
Could have that, yeah.
a department's data set. So if you can look at the legend, so the impact is actually tracked through red arrows, and so department's data set actually impacts other two data sets, which is a flattened employee department and a titles employee department titles data set. And in the same graph, you can actually track both lineage and impact. So Atlas allows you to do that. So what are the use cases for tracking data provenance? So one of them is impact analysis, where you want to look at the chain of custody. And for example, you can have a schema change in a particular data set. For example, if I change the schema of a department's data set, it could actually affect the process and data sets downstream. So data, like engineers or data analysts can actually use that for impact analysis. The other use case is an auditing and a compliance use case. So for example, if there is some sensitive data residing in a data asset, you want to track how was this data set generated, and was it compliant with all the sensitivity requirements, the compliance requirements. This is actually an important use case for tracking compliance with GDPR.
All right. So we've seen a lot of interesting data in the previous lineage and impact graphs, including the SQL statement, which got executed to create a new Hive table, and also how the data came from Scoop. And it's all done by Atlas hooks for the components shown here. So out of the box, Atlas comes with hooks for Scoop, Hive, and Storm. So these hooks monitor for interesting events happening within these components. So in case of Hive, if you like to look at, if you see what happens in Hive, so the interesting events are like when a table gets created, it might be created from a view or from another tables. So Atlas hooks looks at what happened, what are the inputs for the table, and then if a query was run to export the data from a Hive table into a HDFS file, so it tracks the input and output, and it collects all this information and sends to Atlas server via notification, and that's how Atlas captures all this information. So similarly for Scoop ingests data from multiple RDBMS and Teradata, and Atlas hook and Scoop monitors various events and collects the necessary data to populate the lineage into Atlas. And similarly, Storm topologies can deal with read from Kafka topic or publish to Kafka topic, or they can write to HBase, and they can read and write to from Hive tables and HDFS. So Atlas hook in Storm, it actually analyzes what a topology does in terms of input and output, and does the same thing. So it converts that information into a notification to Atlas server, and thereby it can track, first of all, what the assets are out there, and also the data flow between them. And in addition to these three, and you can also build custom integration using APIs. Atlas publishes two APIs, one via Java, and there's a HTTP REST API. You can use both these APIs to publish custom metadata and lineage into Atlas. And once the metadata is available in Atlas, it can be used for various purposes, like you can add classifications to that, and you can enable a search of the data in your cluster. And once you have tags or classifications, it can be used to enforce security policies or masking policies. And here are some partners who integrated with Atlas. For example, Activio, Data Guys, and Waterline. They discover the data, and then they do data discovery, and then they automatically classify the data depending on the sensitivity, and they make appropriate API calls into Atlas to add the classifications. And at Talent, they monitor the lineage of the data flow, and they update Atlas with necessary lineage information. And Cinescope, they, in addition to doing the discovery and classification, they also populate Atlas with data quality information. So we can look at the classification in some more detail. Okay. So classification is a way for a data steward or an external application like the partners we just saw earlier to classify data, to categorize the data in multiple contexts. It can be for any of the reasons they want to classify. It can be for like governance. For example, if you have a data which you leased from somebody else and you want to make sure that the data is not used beyond certain time, then you can add a tag like expires on, and we'll see a couple of demos on this so for governance purpose. And you could have some data which is sensitive. Then you can use classification for the security purpose to make sure that only the right people access the data, and then data is presented in the right form depending on the user role. For example, if you have credit card data or personally identifiable information, you might want to show only masked data for certain user roles. So you can use it for security purpose. But simply if you want to classify the data depending on the business unit where the asset belongs to, then you can create classification for this business unit, in this case like auto insurance, banking, wealth management. So whatever makes sense for your deployment, you can create classifications, and it helps you to search the data using the classification. Okay. So we'll go through some of the use cases for the classifications. So in this use case, in a typical deployment, you will have some data which you call like reference data, which you don't expect to change, which should be read-only for most of the users. So you can classify those with a tag like, see here we are going to use a terminology tag and classification interchange, because earlier we used to call it tag, and now we are calling classification. So you can tag any assert where its data is referenced, which is not expected to be modified with the reference data. And once you add the tag in Atlas, then you can create a ranger policy which would prevent anyone from doing any write-up modification operations. For example, in this case, this is a ranger tag-based policy, which says on HDFS file, if anyone is trying to do a write or a high, anyone is trying to do an update, and this policy would deny the access. So this becomes a very powerful way and simple way for you to make sure that any reference data is only read by most people. And ranger policies allow you to add some exceptions if you want certain users to be able to change it. Ranger policies give an exception. For example, if you have an administrator who you would like to allow updates to this reference data, you can do it via these policies. Then we'll see another example here. So this one uses attributes in a classification. So the earlier use case, we just saw that you can classify data using like just a string, like reference data. But in addition to just a string, you can also add attributes to them. And you can use these attributes to do access control based on the values of this attribute. So we'll see a couple of use cases on this one. The first one is let's see some leased data which users are not supposed to access it beyond certain time. Let's talk about let's see two tables, tax 2009 and tax 2010. Typically, the tax data expires within like 7 years, and after 7 years, nobody should be able to access. So on this table, tax 2009, we'll add one classification called expires on with an attribute called expiry date, and you set the expiry date there. And so on 2009 table, the expiry date is set to 2016-12/31. So any access after this date will be automatically blocked by a ranger policy. And there's another table here, expires on tag, but the date is 2017-12/31. So today, if you try to access both these tables, and the first table access will be denied by ranger policy, and the second table, the access will be allowed for the people who have access to it. Okay. So we'll see a quick example of this. So this is the ranger policy. So the ranger policy is written in terms of tags, which is expires on, and it's nothing. There's no reference to a specific resource in the ranger policy. It all talks about just a tag, expires on. Any data it's tagged as expires on, this policy will kick in, and this policy will authorize the access depending on the expiry date attached to the tag. So another thing to note here is it's not necessarily restricted to one component like Hive. This tag can be used to restrict access to various data in various components, including HDFS, Hive, and HBase. And wherever the Ranger authorizer exists, today there are about like 9-10 components are covered by Ranger authorization. All of them can potentially be controlled by these tag-based policies. So we'll go through a quick demo of this one. So first we'll see access to this table tags 2009. But before we see this, let me quickly show the tag in Atlas. So here I'm searching for the tag expires on, and there are 3 tables tagged with this expires on. So here you can see the value of the tag. Value of the tag attribute is expiry date is 2016 12/31, and moment it is tagged in Atlas, and Ranger receives that by a notification from Atlas, and then once Ranger receives it, and it can enforce the policies written for this tag. So I go and execute this query. So this is running in my little VM, so the response might be a little slow. So you can see that the access has been denied. Right? This is a standard error message users would get. So there is no reference to the access is denied because of this expiry date tag and all. It's just a standard access denied exception given by any Hive command. Now, if you want to see the reason why it was denied, we have to go to Ranger audit logs. We can see that the user admin tried to access this table tags 2009, and the user tried to do a select operation, and the access was denied. And this access was denied by this policy number 4, which is the access expires on policy we just saw earlier. So now let's try to access another table, which is 2010. So in this case, the expiry date is beyond today, which is 2017 12/31. So the query went through successfully, and it got the results. So this also you can see it in Ranger audit logs. So you can see that. So you can see multiple audit logs here. So we can spend a few seconds on this. So here the user did a select on tax 2010, and the select was allowed. And you'll see one more here. So there was a column called SSN, and this SSN column was tagged as PII in Atlas. So let's go to Atlas quickly. So there's this SSN column in the table, and it was tagged with PII. And then Ranger audit log will also show that the user accessed some data which is tagged as PII. And you can go to Ranger and search for all the accesses for a specific tag as well. So this will give a powerful way to investigate based on the tags. So you can go and look at whoever accessed any data which is tagged as finance PII. You can go to Ranger audit and interactively look for all these accesses. Okay. So here's yet another use case for attribute-based access by Atlas and Ranger working together. So let's say you have a table claim saving, and let's say we add one classification here called data quality. Okay. So the requirement is if a data quality is less than 0.5, then we don't want any analyst to access the table. Okay. So that's a requirement which is getting enforced by this Ranger policy. So here there is a tag called data quality, and there's an attribute called score, and the score value is 0.45. Okay. And as we know more about this score, other tools which measure the data quality, they can go and update this attribute. And once the data quality value goes beyond the threshold, then only then the people in analyst group will be able to access it. And that enforcement is done by ranger policies. So here you can see that there's a tag-based policy for data quality. And it denies access to analyst if the score is less than 0.5. As I mentioned earlier, this classification-based policies, they go beyond one component. It's not restricted to, let's say, Hive. So here we can see that there is a classification called trading data set. And there are few HDFS files or folders which have trading data set. And there are few Hive tables have the same business data, like trading data set. All of them you can classify as trading data set, and you can set appropriate access rules for in Ranger. For example, in this case, this would allow anyone in the broker role to be able to access any data which is tagged as trading data set, and everyone else will be denied. And you can extend that for any component. Like I mentioned, there are like 9 components which have Ranger's authorization. And any component where Ranger authorization exists for resource-based policy, and all the tags also, if you tag those resources, and all the tag-based policies will be supported. So in addition to simple text-based classification, and then we talked about attributes in classification. This is another aspect of classification where there is a notion of supertypes or subtypes or derivations in tags or classification. So in this case, you can have a classification called PAI, but there could be other PAI data which is specific to finance and then vendors. And you can have various rules for each of this different classification. For example, for finance PAI, you might want to allow only people from finance team. Everybody else you might want to deny. And if you have a vendor PAI, you might want to allow only partner managers to access it, but everybody else should be denied. But in general, you can say at the base level PAI data, you can say that all the contractors should not have access to PAI data. So in effect, what happens is if any contractor accesses any data tagged as PAI or vendor PAI, and they will be denied as well. Because these tags are inherited by this finance and vendor PAI, and Ranger will enforce the rules which is specified in the base tag-based classification as well. So this is another way you can organize your classifications, and then you can model your authorization. Okay, so
now let's look at how you can actually effectively find data assets in your data lake using the search capabilities that Atlas provides. So for example, let's say you're looking for a Hive table type. So you can actually filter by types here, and you can also filter by classification. So here we are trying to filter for Hive tables which have personally identifiable information. And then you can actually enter a search query here. So if you know the asset name that you're exactly searching for, you can actually type that completely here, or you can use a wildcard to drill down the asset itself. And this could be grouped with logical expressions, including and or. So you can actually group wildcards and logical expressions to achieve your search. So let's look at briefly look at how Atlas captures technical and operational metadata for a given data asset before we move on to advanced search. So if we look at Hive table data asset here, it captures.
Just do a refresh.
It captures various technical metadata. For example, you could track what is the database that it belongs to, and you could drill down into that database, and then you can it also tracks the owner, then this is the name of the data asset, and also what is the table type, if it's a managed table or an external table. And you could also associate and dissociate tags for the data asset here. We also track changes to the metadata itself through audits in Atlas. And you could drill down into the detail. Here a tag was added, which was a trading data set. And this could be tracked over time to capture like what changes happen to the metadata itself. And you could also look at the schema of a data set, in this case a Hive table, and you could drill down into the columns and what tags are actually associated with these columns. So yeah, this is the view that Atlas provides. So let's look at advanced search. So advanced search basically allows you to drill down into data assets which have like specific search requirements. So the user needs to be familiar with the data type or the model that he's searching for. In this case, he's searching for a Hive table where the name has employees and the owner is Hive. So he needs to know what is the attribute that he's searching for. And yeah, so the other advantage that the advanced search provides is a way of programmatically constructing the query dynamically. So for example, you could have a query builder built on top of this. And you could also specify selected attributes that you want to retrieve as part of the query in the advanced search. So another complicated search that you could do is an example that's listed here. So you want to retrieve all the Hive columns wherein a table is named as belonging to a table named impressions and in a database named raw. So the table is actually an attribute on the Hive column type, and the DB is actually an attribute on the table type, and the name is actually an attribute on the database. So it allows any form of nested attribute searches in the advanced search. So that's the major difference here. So now we'll take a look at the Atlas architecture. So as we mentioned earlier, so it captures metadata from a bunch of components like Hive, Scoop, or Storm. All of this metadata is actually ingested in real time and pushed to Kafka as notifications. So the reason we chose Kafka is it provides durable and reliable message delivery, and also it keeps the whole process asynchronous. And Atlas is decoupled from the data ingestion part, metadata ingestion part. So once data is available in Kafka, it is ingested in real time through the ingest module in Atlas, and which actually transforms these into an internal representation so that it's optimally stored inside Atlas as a graph. So the reason we chose the data structure to be a graph is because a graph allows you to model rich relationships between data assets and also between transformations on data assets. So the graph database that we use here is Titan. So Titan is actually a property graph database. So you could essentially have vertices and edges, and you could have properties on these edges and vertices. So we use these properties to actually model the attributes on the Hive table type that we talked about, like owner and the other properties. So these properties could effectively be indexed as well for efficient searches. So Titan actually stores these vertices, edges, and other properties in a metadata store or HBase. And it also indexes these properties basically maintains a reverse index for these properties in Solr. So since it uses HBase in Solr, it's horizontally scalable and it scales pretty well. And to abstract out various versions of Titan and also to be able to plug in other graph databases, there was work done by folks from IBM for graph abstraction. Yeah, so you could plug in any graph database which sticks to these to this interface. And for modeling the types or the models for different types of data assets that we talked about, like Hive, etc., or which are, yeah. So there is the type system module which handles model ingestion, and it also ensures that type checks are done whenever metadata is ingested into Atlas. There's also a search interface which actually translates all the search queries from free text and advanced into a Gremlin search, which is an abstract graph search that could be fired on various graph databases, and it abstracts out the graph implementation. So there are APIs provided on top of all this for easy use, and so there are applications built on top of these APIs. The Atlas UI itself is built as an application on top of the APIs that Atlas provides, and the business glossary will be an application which is in the roadmap. And the metadata changes themselves are tracked through, are actually tracked and published as notifications to interested consumers. Ranger is one of the consumers of these notifications, and it actually tracks changes to classification associations with data sets and applies policies in real time.
Okay. So let's look at a few roadmap items we are currently working on. Business taxonomy or glossary, this is one of the very interesting items, and there's extensive discussion going on in Apache JRAs. And IBM team is contributing a lot in this one based on their experience in the metadata domain. And we believe this is going to take Atlas to a next level and in terms of usability, and then how it can be used in various domains. So there are a few advantages of this business taxonomy listed here. So I just got a mark that it's only 5 minutes, so let me just run through this. And then so we saw that out of the box, we have few connectors like Scoop, Hive, and Storm. There's a lot of ask for connectors to Spark and NiFi, HBase, and we are prioritizing on them. And that's these are some of the things we'll take in the immediate future. And then on the Hive, we saw lineage from table level, table and view level. And there's also a lot of ask about column level lineage. So if you have a Hive table which derives value from 3 different, let's say, views or column, 3 different table columns, and they would like to track the column level lineage. So this information is available today in certain use cases, like when a table is created using CTAS, like create table as select. This information is available to Atlas Hook, so we are able to make it available in Atlas. But there are some gaps which we are working with Hive team to address it. So this is one of the important use item we are tracking for the next release. And then being able to search or filter based on the lineage information available, especially if you have a long lineage, like maybe like 20 path, and it might be very difficult to find what's going on in the lineage. And one of the asks is to be able to search within the lineage, to restrict the lineage to, let's say, certain types or certain names. So we are working on that. And then the last item listed here is we are working on export and import of Atlas lineage metadata across instances. So these are some of the asks from folks who deploy in the test and the production environment. So we provide an export and import functionality. Okay. So we probably have like 3 or 4 more minutes. So now we'll open up for Q&A. Yes, please.
Column level lineage was coming version 8.0. Sorry, I thought column level lineage was there in version 0.8.0, so would be in HTTP 2.6. Is that not the case?
Yes. It's partially available, mainly because some of the information is not provided to the hook in Hive. So it's available. There are few cases, like if you are using Hive 2, which is LLAP, then column level lineage is available in Atlas. And even if you use Hive 1, which is like Hive Server 2, then it's partially available. When you create a table from other tables, it's available. But if you create a view from other tables, there are some gaps in the Hive APIs where we don't have access to the data. So we are working Hive team to address that. So it should come in one of the next patch releases.
Okay. And then just one other question. How do you go about tidying up metadata? So when tables have been deleted or removed, or I want to remove metadata from the Atlas Datastore, how do you do that? Because I've not found any way to do that through the UI.
Right. So today, there is no way to delete data from Atlas, and that's right now it's by design because this is meant for governance, and you don't want to lose any data. But some of the pain points for the users, I understand, like they create some test tag, and they just want to get rid of the test tag. So we have been asked about this feature for a long time. So this should be coming in one of the next releases.
Okay, thank you.
In a limited way. We don't want people to go and delete other data, like classification is added. We still want to have the trace in Atlas that this table existed, there's a table derived data from other places. We don't want that to be gone. But if you want to just clean up something which is a test information you just added, we will provide APIs to clean it up.
Okay, thank you.
Thank you.
Time is up.
Okay. Thank you so much for attending. And I know this summit, there's a lot of talk about Atlas and Ranger security governance. We are so excited about it. If you have any questions further, we'll be outside. You can just catch hold of us. Thank you so much.